All right, so lesson 5.5 is on the law of sines. It starts on page 125 of your notes packets. We'll start by defining the law of sines. In any triangle with angles A, B, and C, so if we draw a triangle here, A, B, and C, and opposite sides, A, B, and C. So notice lowercase a denotes a side length, capital A denotes an angle, and the lowercase a is opposite of angle A. Side B and C are opposite angles B and C. The following equation is true. Sine of angle A divided by side length A is equal to sine of angle B divided by side length B, which is equal to sine of angle C divided by side length C. How can we use this? Let's take a look at example 1. In example 1, we're looking at either AAS or ASA, so two known angles and one known side. So solve triangle ABC, we'll again draw a picture. ABC, given that angle A is 36 degrees, angle B is 48 degrees, and side length A is 8. Notice side length A is opposite angle A. Immediately, because we have two angles of a triangle, we can find the third angle. So 36 plus 48 equals 84. And then we take the total of angles of a triangle, which is 180, minus 84 to get 96. So we know that angle C is 96 degrees. Now using the law of sines, we can find the other two side lengths. So sine of angle A, sine of 36 degrees, divided by the length of side A, which is 8, equals sine of angle B, 48 degrees, divided by side length B. Solving for B, we can use the cross product. B times sine of 36 degrees equals 8 times sine of 48 degrees. Divide both sides by sine of 36. B equals 8 times sine of 48 degrees divided by sine of 36 degrees. Let me move the camera down here. Okay, using a calculator, we can approximate that to be 10.11. So that's side length B. We're going to use the same process for side length C. Sine of 36 degrees divided by 8 equals sine of 96 degrees divided by C. Using the cross product, we can find that C times sine of 36 degrees equals 8 times sine of 96 degrees. Divide both sides again by sine of 36 degrees. C equals 8 times sine of 96 degrees divided by sine of 36 degrees. Using our calculator, we can approximate C to be 13.54. So now we've found all three angles and all three side lengths, but to notify that here, the measure of angle A is 36 degrees, side A equals 8, measure of angle B is 48 degrees, the measure of side B is approximately 10.11, measure of angle C is 96 degrees, the measure of side C is approximately 13.54, and that will be your final answer for this example. All right, in the next example, we're looking at a triangle ABC. So again, we'll sketch a picture. Triangle ABC. Given that side A is 7, side B is 6, and angle A has a measure of 26.3 degrees. So now we're looking for one remaining side and two remaining angles. Again, we can use the law of sines. So we'll set up sine of A divided by 7 equals sine of B divided by 6. Solving for B now, multiply both sides by 6. So we have sine of B equals 6 times sine of A divided by 7. We do know the value of A, so we can actually substitute in 26.3 degrees Now we'll use our inverse function again and find that b equals sine inverse of 6 times sine of 26.3 degrees divided by 7. And when you put this into a calculator, it is approximately 22.3 degrees. So now we have a value for the angle B. Now we want to find the measure of angle C. And we can do that by saying, I know 2 of the angles in the triangle. To find the third, I need to subtract them from 180. So 180 degrees minus 26.3 degrees. And then we'll subtract again the 22.3 degrees. So with our placeholder, and you'll find that that is 153.7 degrees. And this is 131.4 degrees. So the measure of angle C is 131.4 degrees. And now we can use the law of sines to find the length of side C. That's the only thing that we don't know yet. So we can say sine of 26.3 degrees divided by 7 equals sine of 131.4 degrees divided by C. Solving for C, we can get sine of 26.3 degrees times C equals 7 times sine of 131.4 degrees. So then C equals 7 times sine of 131.4 degrees divided by sine of 26.3 degrees, which is approximately 11.85. So again, we have measure of angle A equals 26.3 degrees. Side A has a measure of 7. Measure of angle B is 22.3 degrees. Side length B has a measure of 6. Measure of angle C is 131.4 degrees. Side length C is 11.85. And that is your final solution for example 2. All right, the next 2 examples are very similar. You'll use the law of sines to populate the rest of the values for the measures of a triangle. The last example is a word problem, so think through the setup and then apply the same procedures. Once you finish those, reflect upon what you've learned and write a short summary in the box provided.